Another little bit about why algebra is so powerful when you're dealing with maths. Not when you're dealing with perhaps other things, but with maths it's very powerful. So you got ax plus b is equal to c, and we rearrange this to get x on its own. We should know by now that we get ax is equal to c take away b, and in fact later on you might be able to skip that step altogether and just go straight to the answer. X is, get rid of the multiplying by a, you divide by a. So x is c minus b over a. That tells you where to put the bits in any equation which has got this particular form. We could have 3x plus 1 is equal to 7, or 2x minus 1, 2x plus 1 is equal to 11. So if we compare this with this, now this isn't particularly something you actually do, but the a is replaced by 3, the b is replaced by 1, and the c is replaced by 7. Now you can jump, so if we actually write those in, you can then do this thing in one shot. Ax plus b is equal to c, 3x plus 1 is equal to 7. So x is equal to, I'm looking here, c minus b divided by a. C is 7 minus b, which is minus 1, divided by a, which is divided by 3. 7 take 1 is 6 over 3, which is 2. So you just sort of rearrange it in one shot, so to speak. Again, ax plus b is equal to c. So you can solve that. X is equal to, referring back to this, c, 11, take away b over a, 2. Which is 10 divided by 2, which is 5. Okay, I'm going to finish it up with something which is going to stretch you a little bit, but maybe you can get it and you'll realise that some of the really complex maths isn't that complicated at all. Let's just make up something which looks impossible. Ay squared minus c, all square rooted, divided by pi, all of that thing squared is equal to w. Okay, so we've got a certain way of using brackets here. It's a particular order. Again, it's just all about the order that things happen to the letter we're trying to get on its own. Let's use y equals something. Now I'm going to try and just do this in one shot. Okay, so if you can understand this, then you've come a long way. Trying to get y on its own. Sentence says, first of all, we identify the order. Take y, square it. Then, when you've worked that out, multiply the answer by a. When you've worked that out, subtract c from it. When you've worked that out, take the square root of all of that. Then, divide the answer by pi. And when you've worked all of that big lump out, finally, you square the whole thing, the whole expression. And I'm going to do it now in one go to get y equals. So we start with w. And remember, the rule is you unwrap things in reverse order that they were applied. So the first thing that we attack is the squaring. The opposite of squaring, we square root it. So that's done. 6, 5, 4, 3, 2, 1. Operation 5 is dividing by pi. The opposite of dividing by pi is multiplying by pi. Done. Then we get rid of number 4, which is square rooting. The opposite of square rooting is squaring, so we square the whole of the right hand side. Put brackets around it and put a little squared there. Then we get rid of minus c. The opposite of minus c is adding c, so we add c to that side. Get rid of 2, which is timesing by a. Opposite of timesing by a is dividing by a. And then finally squaring. The opposite of squaring is square rooting. So we square root the whole thing. So to write out again, y is equal to pi root w squared plus c all over a, all square rooted. That's not so hard. That's not such a leap forward as to doing just 2-step equations. That's a 6-step rearrangement, but it's not that far away. James and Ashley don't understand that. I'm sure Lucy will. But yeah, once you can start seeing structures, the way that things are set up in these things, then like what looks really complicated is actually not that complicated, and you can look really brainy. Okay, from Sri Lanka, bye.